Hi, hello everybody. Welcome back. So today we are going to have a session wherein I have compiled all the previous year CSIR net questions from 2011 to 2025. Okay, so let's try to do them. All the questions are from periodic properties. That is from general inorganic chemistry. Okay, so let's start. First question. Among the following pairs, the question was asked in NET 2011. Oxygen, sulfur, nitrogen, phosphorus, phosphorus, arsenic, chlorine, iodine. Those in which the first ionization energies differ more than 300 kilojoules per mole R. Four options are given. So first of all, any questions of these type, you should write down a skeletal view of the periodic table. See what are the elements given: nitrogen, oxygen, phosphorus, chlorine, iodine, etc., etc. So let's try. Okay, so nitrogen is there, oxygen is there, fluorine is there. Sulfur comes below oxygen, nitrogen. Phosphorus comes below nitrogen. Phosphorus, arsenic. Arsenic comes over here. Chlorine, iodine. So this is fluorine, chlorine, bromine, iodine. Okay. Now the question is, which among these sets, among these pair, which of the following will differ more than 300 kilojoules? So now understand that 300 kilojoules is pretty high. Now the trend that we know is as we move from left to right, ionization energy increases. And as we move from top to bottom along a group, ionization energy decreases. Correct? This is something that we know. But how much does it decrease? That is important. Okay. For example, fluorine, chlorine, bromine, iodine. I'm just telling you an example. Let's say that from fluorine to chlorine, I'm just taking arbitrary values so that you can understand. This might be 100 units of ionization energy. For chlorine, let's say it dropped significantly, probably 40. The next drop, so can you see the difference? Difference over here is 60 units. The next drop of ionization energy from chlorine to bromine will be even smaller, probably 20. So can you see the difference? Only 20 units difference. And from bromine to iodine, just 10. All right. So what I'm trying to say is as we move down the group, it is true that the ionization energy decreases, but the differences between the adjacent elements along a group, that will keep on decreasing. See, highest is here and then 20 and then 10. So this is the trend. For any property, all the properties, this is a trend. The differences between the adjacent species within a group, that difference would keep on decreasing. Okay, so over here, what are the options given? Oxygen and sulfur. So this is given in option A, or the first one. Then nitrogen and phosphorus. This is 2. Then phosphorus and arsenic. This is 3. And then chlorine and iodine. This is 4. Correct. So as I said, the differences between the adjacent properties will be highest at the top of the periodic table. The differences will be highest at the top. Okay. Meaning nitrogen and phosphorus is at the top. This is second period. This is third period. Oxygen and sulfur is also at the top, second and third period. So 1 and 2, that is option B. 1 and 2 will have the largest differences of first ionization energies. Gradually, when you move down, the differences in the ionization energies will drop. Okay, so this is a trend that you should know for any property. Next question. The size of the d orbitals in silicon, phosphorus, sulfur, chlorine. Again, you should know the order. Silicon is 14, phosphorus is 15, sulfur is atomic number 16, chlorine is over here. Follows the order. So they are asking about the size of the d orbitals, or in other words, it's just the atomic size. It's simply the atomic size that they are talking about. Correct? So we know that along a period, what happens to the effective nuclear charge? Effective nuclear charge increases, as a result of which the electrons come more closer to the nucleus. They come more closer to the nucleus and size decreases. Correct? So chlorine will be the smallest. Chlorine will be the smallest. So you can see chlorine is smallest over here, it is smallest over here. So it's not option B, it's not option A. Silicon will be the largest because it is in the extreme left among the options. So D should be the answer. Silicon, phosphorus, sulfur, chlorine. Right. Option D. The electronegativity difference is the highest for the pair. Again, whenever such questions are given, I repeat again and again, you should have a skeletal view of how the periodic table will look like. So lithium, sodium, potassium is given. So we know lithium, sodium, potassium. Okay. And then across lithium, we have fluorine. Across sodium, we have chlorine. And that's all. These are the elements that are present. Right. So over here, the question is electronegativity difference is the highest. That is the question. Electronegativity difference. So let's try to understand the trend first. As we move from left to right, what happens to the electronegativity? Electronegativity increases. Sorry. Z effective increases, electronegativity increases. So over here, fluorine is the one with highest electronegativity among whatever is given in the option. Fluorine is the element with highest electronegativity. And as you move down the group, your electronegativity decreases. Your electronegativity decreases. Correct. That means among the options of lithium, sodium, and potassium, potassium will have the lowest electronegativity. Okay, so we have identified this much. So the lowest is identified, the highest is also identified. The question is, the electronegativity difference is the highest. It will be the highest for, see what are the options? Lithium and chlorine. Potassium and fluorine. Highest one minus lowest one will of course have the greatest difference. Correct? So now no doubt the correct option is option B. The difference between the highest and the lowest. Option B is the correct answer. Question which was asked in December 2012. All right. Which of the following pairs has the highest difference in their first ionization energy? Let's draw a skeletal view of the periodic table. Let's look at the elements what are present. Xenon, argon, krypton, neon. So these are all noble gases. Neon, argon, krypton, xenon. Okay, from the options. Then you have sodium. Sodium comes in the, so this is the second period. Sodium comes over here. Correct? This is 10, this is 11, this is 18. Correct. So sodium, do you have lithium? No. Sodium, potassium, rubidium, and cesium. This is how we have. This is how it is. Okay. So we have got a skeletal. Now this belongs to group 18 and this is group 1. Group 1. Now they have given certain pairs. For example, xenon and cesium. Xenon and cesium. So this belongs to the 5th period and this belongs to the 6th period. The question is, which has the highest difference in their first ionization energy? First ionization energy. So again, group 1 is always S1 and group 18 is noble gas configuration. Correct? So S1 people will usually have very low ionization energy and noble gases will usually have very high ionization energy. Now the question is which has got the largest difference? So let's look at the different pairs that are given. Xenon and cesium, which is at the bottom. Next comes krypton and rubidium. That is the second option, krypton and rubidium. Third option is argon and potassium. Argon and potassium. And the last option is neon and sodium. Neon and sodium. Okay. This is same like the previous question that we did. That means as we move down, the differences become less and less significant. Always, the differences will be highest at the top of the periodic table. I repeat, the differences in the property of the whatever property, let it be ionization energy, electronegativity, second ionization energy, third ionization energy, electron gain enthalpy, whatever it is. Okay, so the changes, if it follows a trend, that differences will be the highest at the top. And then gradually the differences will decrease. So of course, at the top, we have neon and sodium. So it's going to be option D. Option D, question asked in June 2013. All right. Easy question. The correct order of the sizes of S2 minus, S2 plus and S4 plus species is question asked in June 2014. So we already know that as your positive charge increases on a particular species, as positive charge increases, the size decreases. And as negative charge increases, your size also increases. So over here, S2 minus has got the highest negative charge. Correct? So S2 minus will be larger in size. Then comes the neutral species. After the neutral species, you will have S2 plus and then S4 plus. Why? Because S4 plus has got 4 positive units of charge on it, which will be the smallest. As positive charge increases, size decreases. So which is the correct option? C. C is the correct option. C. Next question. The correct order of decreasing electronegativity of the following atoms are question asked in June 2014. So there were 2 questions which was asked in general inorganic chemistry in June 2014. Okay, so let's make out a rough view of where these elements are placed in the periodic table. So we have arsenic, aluminium, calcium, sulfur. Yeah, these are the 4 elements. So let's start. Arsenic is below nitrogen. Okay, so nitrogen, phosphorus, arsenic. Okay, then you have aluminium. So this is 15. You have silicon over here and you have aluminium over here, 13. Right. And then you have among the options calcium as well. So calcium will come over here. Potassium is here. Sorry, not potassium. Magnesium. Magnesium is above calcium. Correct? And then you have aluminium, silicon, phosphorus, so on and so forth. Calcium is here, arsenic is here, and then you also have sulfur in the question. You also have sulfur in the question. Okay, so this is the rough overview of how it looks. I'll bring it to the center. This is how it looks. Okay. So the question is regarding electronegativity. Electronegativity. what is the general trend? The general trend is as we move from left to right, electronegativity increases. And as we move from top to bottom, electronegativity decreases. Correct. So from here, we can understand that calcium, which is at the left end and bottom, will be the lowest. Correct? Because along a period, as you move from left to right, the electronegativity increases. And along a group, as you move from top to bottom, the electronegativity decreases. So this is at the lowest point. So calcium will be the lowest. And you have only one option like that, which is option B. Let's check the others also. It's option B. Option B is the correct answer. Okay. So calcium will be the lowest. Then, okay, so that is done. Now what is left? You have sulfur, arsenic, and aluminium. Correct. These are the species that you have. And of course, you know, as you move from left to right, the electronegativity increases and hence sulfur will come first. As you move from left to right, electronegativity increases and sulfur will come first. So sulfur is at the top, calcium is at the bottom. Again, if you compare aluminium and arsenic, arsenic is on the right, aluminium is on the left. There might be a confusion. So here they have not played much with that. Arsenic actually has got higher electronegativity than aluminium despite being in the third period. Sorry, fourth period. This is in the fourth period. Okay, that is because as you move from left to right, your Z effective increases and hence electronegativity is also high for arsenic. Okay, so the correct trend is sulfur, arsenic, aluminium, and calcium. Option B. Easy question. Among F minus, N plus, O2 minus, Mg2 plus, the ones having the highest and the lowest ionic radii respectively are. The principle is size of an atom or an ion is directly proportional to the negative charge and inversely proportional to the positive charge. So if we can see, all of these are isoelectronic species. F minus, 10 electrons, N plus, 10 electrons, O2 minus, 10 electrons, Mg2 plus, 10 electrons. So as the amount of positive charge increases, size decreases. So in that case, Mg2 plus will be the smallest, then Na plus. And as your negative charge increases, your size also increases. Correct. So for that, we have F minus, and then the largest one is O2 minus. So the question is to find the largest and the smallest. Correct. So this would be the largest and Mg2 plus would be the smallest. O2 minus and Mg2 plus is the answer. Option C is the correct answer. Question asked in December 2014. Next question was asked in December 2017. The first ionization energy is the lowest. Lowest for which among the following? So let's try to write them out. You have phosphorus, nitrogen, oxygen, fluorine. Okay, so we have phosphorus, which is below nitrogen. We have arsenic, which is below phosphorus. Oxygen, sulfur, selenium. Also, we have in the option. Fluorine, chlorine, bromine. Okay, so what are the elements of interest? We have phosphorus, bromine, selenium, and arsenic. The question is to find the species with the lowest ionization energy. Easy. As you move from left to right, ionization energy increases. And as we move from top to bottom, ionization energy decreases. Right. So, if we look like that, if we move from left to right, what happens? Here, though, it's not Brahmin. Why? Because the ionization energy will be very high. Now, over here, what you have to pay attention to is, if you just look at the trend, you will go and mark arsenic because that is at the end, which is the lowest. But no, be careful. Be careful. This particular group of nitrogen is half filled. Correct? What is the configuration of nitrogen? 1s to 2s2? 2p3. This is 3p3. And this is going to be 4p3. So removing an electron from a half-filled orbital is of utmost difficulty. It's very hard. So it's not going to be phosphorus. It's not going to be arsenic. It's not bromine either. The correct answer is selenium. Option B is the correct answer. Option B. So be careful with it. Important question. Allred-Rocco electronegativity of an element. Question asked in December 2017. The same question was repeated in 2020 as well. So first of all, we should know what is the equation of Allred-Rocco electronegativity. So according to which the electronegativity found by this method is equal to 0.359 into the Z effective of the species divided by R square plus 0.744. Plus 0.744 is another term. It is second term. Okay, it's like this. So this is the equation corresponding to Allred-Rocco electronegativity. So if you don't know this equation, you won't be able to mark. So let's look at the options. Directly proportional to the effective nuclear charge. Yes, that means A is true. If A is true, it's not option C. It's either A, B or D. Next, directly proportional to the covalent radius. No, it is inversely proportional to the square of the radius. So B is wrong. C, inversely proportional to the square of the covalent radius. Yes, that is true. Correct? So Allred-Rocco electronegativity is directly proportional to Z effective and inversely proportional to R square. Option B is the correct answer. Among the elements, zinc, gallium, germanium, arsenic, the one with the lowest first ionization energy is. So let's start. You have boron, carbon, nitrogen. That is enough. Now the elements are arsenic comes below phosphorus. Phosphorus and you have arsenic. Correct. Now gallium is there. Boron, aluminium, gallium. Carbon, silicon, and you have germanium. Okay. And then zinc is over here. So this is 31 and this is 30. Okay, so the question is among the elements, gallium, germanium, zinc, and arsenic, the one with the lowest first ionization energy. So first of all, understand that all these species over here are half-filled. Correct? They are half-filled, so it is very hard to pull out an electron from that group. So that is not going to be the lowest. Zinc, whose d orbital is already full. What is the configuration? You know that it's 4s2 3d10. It's full. Correct? So this is fully filled. So it's not zinc. It's not arsenic. So it's either gallium or germanium. So now let's look at the general trend. What is the general trend? As we move from left to right along a period, Z effective increases. As a result, size decreases. And if size decreases, ionization energy increases. So if you compare gallium and germanium will have lower ionization energy than germanium. and hence the correct answer to this question would be gallium. Option C would be the correct answer. Beautiful question asked in June 2018. Identify the correct statements about the electronegativity of groups given below. The first one is CF3 and NF2. So CF3, as we know, is sp3 hybridized carbon and NF2 is sp3 hybridized nitrogen. The end atoms are same, correct? Fluoride, here also it is fluoride. So we can compare the electronegativities of the central atom directly, and we can say that electronegativity of N is higher than F. So CF3 group will have lower electronegativity than NF2. Okay, so statement A is wrong. If A is wrong, option A is also wrong. Next, NH2 group has lower value than NF2. That is obvious. So this is NH2 with two hydrogens attached. Here it is NF2. So there are extra fluorine moieties over here, which will of course increase the electronegativity. So NF2 will have higher value than NH2. That is what is given as well. NH2 group has lower value than NF2. That is true. So B is true. That is there in all the options. Next, OH. OH. So you have OH and the other one is NF2. Okay, now here you cannot compare the central atoms. Let me tell you why. Why? Because here the end atom over here is hydrogen and over here the end atoms are just F, fluorines. So you cannot compare the central atom. You should compare it as a whole. The environment has changed. Okay, the environment has changed. So NF2, nitrogen, is attached to two fluorines. So there would be a pull of electrons towards this fluorine, and as a result, it will attain partial positive charge on the central atom, and hence NF2 is larger than OH. It's not OH which is larger than NF2. NF2 is larger than OH. So option C is wrong. If C is wrong, this is wrong, this is wrong. The correct answer should be D. Correct answer should be D. So let's see what is the last option. Statement. CH3 and C2H5 have almost similar values. Yes. Okay. They are kind of similar. It's just one CH2 extra. So C is correct. All right. Statement type questions asked in 2020. The correct statement among the following with respect to the ionization energy. First one, ionization energy, the first one, second one, and third one, and you take the sum, for indium is more than that of aluminium. Never, never. Why? Because it is boron, aluminium, gallium, indium, and thulium. This is how it is. So indium is below aluminium, and always as you move down the group, ionization energy decreases. Ionization energy to decreases. So statement 1 is wrong. So it's not option C. Next one is the ionization energy of scandium is higher than that of cobalt. So yeah, we have learned about the size, correct? That second period is very important. Scandium, titanium, vanadium, chromium, manganese. Then iron, cobalt, nickel has got similar sizes. And then suddenly what happens? Copper and zinc, because of the electron-electron repulsions, are larger in size. So this is the order of size. This is the order of size. So if you compare, what is the question? They have asked us to compare scandium and cobalt. Yeah, scandium and cobalt. So scandium and cobalt means scandium is higher or larger in size than cobalt, correct? As a result of which its ionization energy of scandium will be smaller than cobalt because the size is huge. So ionization energy will be small. So 2 is also wrong. So it's not option A, it's not option D. Correct answer should be B. We found it just by cancelling the options. Let's look. Okay, let's look how it is. Ionization energy of gallium is higher than that of selenium. Okay, so for that we need the periodic table. So this is gallium, position of gallium. Then what do you have after boron? Boron, carbon, nitrogen, oxygen. Okay, and oxygen, sulfur, selenium. Okay, so the question is to compare gallium and selenium. Ionization energy on moving from left to right increases. Correct? So selenium is towards the right, and because of which the Z effective also increases. So ionization energy of gallium is lower than selenium. That is true. That is true. Next one, ionization energy of nitrogen is greater than oxygen, of course. Of course. Why? Because this is half-filled system P3. Oxygen is P4 system. Half-filled systems will have higher ionization energy, and hence statement 4 is also correct. So 3 and 4 are correct. Option B is the correct answer. Another question asked in November 2020. Mark this is important because it does not follow the general trend. This question does not follow the general trend. Look at the metals which are given over here. It is zinc, cadmium, and mercury. This is the order, actually. Actually speaking, this is how they are placed in the periodic table, zinc, cadmium, mercury. So what we might expect is the first ionization energy as we move down the group. As we move down the group, ionization energy decreases. This is what we expect. But this trend is not followed here. This particular trend is not followed here. Okay? It's an exceptional case. The actual values of ionization energy is highest for mercury and then zinc and cadmium. Mercury has come to the first place. It is an exceptional trend shown. So we might think that it is mercury is the lowest, and then cadmium, and then A, and then zinc. We might mark A, which is there as the first option according to the general trend, but no. Okay, it's actually D. Mercury comes first and then zinc and cadmium. B. Mark this question as important. Repeated question from Allred-Rocco electronegativity. According to the Allred-Rocco electronegativity equation, electronegativity is equal to 0.359 Z effective by square of the covalent radius plus 0.744. So what are the statements? Electronegativity is directly proportional to Z effective. Yes. Inversely proportional to Z effective. No. Inversely proportional to the covalent radius. No. Inversely proportional to the square of the covalent radius. 1 and 4 are correct. Option A is the correct answer. This is a repeated question which was asked in earlier years, repeated in 2020. The correct order for the electron affinity for one electron gain. For one electron gain of the following elements. Okay. So first option we know electron affinity, electron gain enthalpy is the highest. See what are the groups given over here. So group 17. Group 17 is actually fluorine, bromine. The order of electron affinity is highest for chlorine, then fluorine, then bromine. So that is wrong. It's not A. Then group 15 is there. So we have nitrogen, phosphorus, arsenic, antimony. We have only this much. So the actual order over here is arsenic, antimony, bismuth, then phosphorus, and then nitrogen. Is that the order which is written? No, arsenic is over here. So it's not option B as well. Okay. Then group 16 is also given. That is option C, group 16. This is something that we discussed in our class. These are all those trends that are not following the general equations. Okay. So we have oxygen, sulfur, selenium, tellurium, polonium. And what was the trend of electron affinity? It is sulfur is the highest, selenium, tellurium, polonium, and lowest is oxygen. Okay. Sulfur, selenium, oxygen. That is the trend which is given over here. So C is correct. Correct option is option C. Let's look at D also. Lithium, sodium, and potassium. Lithium, sodium, potassium. Actually, this is just following the general trend. As you move down the group, electron affinity will decrease. So it's actually lithium, which is the highest, then sodium, and then potassium. That is wrong. So option C is the correct answer. Option C is the correct answer. Next question. The correct order of second ionization enthalpies. Question asked in June 2023. Second ionization enthalpy. So we already know that boron, carbon, beryllium is there. Beryllium, boron, carbon, nitrogen. What is the actual configuration? 1s2, 2s2. 1s2, 2s2, 2p1. 1s2, 2s2, 2p2. 1s2, 2s2, 2p3. This is the actual configuration. After the first ionization energy, this becomes 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, right? And 1s2, 2s2, 2p2. So this is not the question. The question is to find the second ionization energy. Second ionization energy. Correct. So over here, we have beryllium, 2s1 and boron. So if we compare beryllium and boron, this is 2s1 and this is 2s2. So this is a fully filled configuration. So we can say that 2s2 will be having higher than beryllium. Next is carbon. This is 2s2 and this is 2p1. So here it is again a fully filled configuration. So boron will be higher. Correct? And then if you compare carbon and nitrogen, it is not fully or half filled. And penetration powers are also the same. So the last thing that you'll be comparing is Z effective among the adjacent species. So carbon and nitrogen is higher in Z effective, correct? And hence this is the actual order. All right. So if we compare as a whole, always the one which is at the noble gas configuration is not there over here. We don't have any. Oh, just a second, please. Okay. So as we compare as a whole, this is not the trend which is given. They have arranged in a proper decreasing manner. Okay. So here nitrogen, which is at the right end, will be having the highest ionization energy. So it's not A or B. See here, boron is kept in the front. No. Nitrogen, which is having the highest, will come here. Correct. Then comes boron. Then carbon and beryllium. Option D is the correct answer. Option D. So here itself you can cut out B because here beryllium is shown to have higher than boron. No, boron has higher than beryllium. Okay, so please be careful with such questions. These are very tricky, might seem very easy, and you might end up getting negative marks. So no. Mark this question as important. X, Y, and Z are three p block elements in the second row of the periodic table. So we know that the second row is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. With electron affinities, very important over here, they have used the term of electron gain enthalpy as electron affinity. Okay? So during our classes, we did learn that electron affinity is the negative of electron gain enthalpy. But over here, what they have done is they have used the terms interchangeably. Okay. And they say that the electron gain enthalpy or affinities, both are taken to be the same in this question, is minus 15 for X, minus 142, and minus 333 respectively. Okay. So that means the electron gain enthalpy or the affinity is highest for this particular species, Z. Now, it will be good if you know this, that usually halogens have electron gain enthalpies as high as minus 300 kilojoules per moles. Okay. They have very high values. So from this, you can understand that Z is a halogen. So it is said that in the second period, so it should be probably fluorine. So this is Z. Then what do you have over here? You have oxygen, nitrogen, carbon. Okay. And electron affinities are given. So let's say this is X and this is Y. You can take any value. Let's assume. Okay. So we have already assigned this. Y has the highest first ionization energy. No. Y won't have the highest. See, as you move from left to right, ionization energy will increase. So Y is in between. So it's not A. X has the most number of p electrons. No. As you move from left to right, the electron number will increase, and that is for Z again. So B is also wrong. C and D, if you compare, C is X has the highest proton affinity. D is Z has the highest electronegativity. That is true. Nitrogen, oxygen, fluorine. Fluorine has got the highest electronegativity. So the correct option is option D. Now, how do you determine proton affinity? Proton affinity is related to the electron density. Okay. Higher the electron density, higher will be the proton affinity. So over here, fluorine is the smallest and has got the maximum number of electrons. So this will be having the highest proton affinity. It's Z. It is Z. So C is also wrong. D is the correct answer. Option. Next question. The differences in the second ionization energies of, and they have taken the ratio, lithium by sodium, beryllium by magnesium, boron by aluminium, nitrogen by phosphates are represented as X1, X2, X3, X4. The correct order of second ionization energies. Okay, be careful with this question asked in December 2023. So if we take lithium, beryllium, boron, carbon, 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p1, 1s2 s2 2p2. So after the first ionization energy, this becomes 1s2, 1s2 2s1, 1s2 2s2, 1s2 2s2 2p1. Now we have to compare the second ionization energy. Correct. Now we have to compare the second ionization energy. So while comparing the second ionization energy, let's try to compare. Look at the configurations. 1s2 and 2s1. 1s2 is a noble gas configuration. So lithium will be higher than beryllium for sure. Okay, so this has become lithium plus and this is beryllium plus. Okay, then you compare beryllium and boron. Again, boron, just a second, please. Yeah. Okay. Yeah. Now, if we compare, do we have nitrogen? Okay. Lithium, beryllium, boron, and it's nitrogen, not carbon. Okay. Sorry. Nitrogen. 2p3. Oh, this is 2p. Okay, I'm sorry. Okay. So if we compare lithium and beryllium, lithium has got a noble gas configuration, so that will be highest. Then beryllium and boron, of course, this is fully filled, so boron plus will be the next. And then finally, nitrogen and boron P. This is 2s2 and this is 2p2 and these are not adjacent. Understand that you cannot compare in terms of penetration power because they are not adjacent. So you will have to take into consideration the Z effective. Z effective of N plus is higher and as a result, the ionization energy will also be higher. Okay. So noble gas configuration, lithium plus will show the highest, then N plus, then B plus, and then Be plus. So the same trend will be followed by the next period also. Sodium plus, then below nitrogen we have phosphorus, below boron we have aluminium, and below beryllium we have magnesium. If this is the trend, the ratio will also follow the same trend. So lithium by sodium, which is X1, will show the highest value. It's not C. And beryllium by magnesium, which is X2, will show the lowest. That is, it's not D. Nitrogen by phosphorus, which is X4, will be the second. So this is X1, X4, X3, and finally X2. Option A is the correct answer. Why did lithium come first? Because this is a noble gas configuration. That's it. Okay. Last question. Among the following, the incorrect statement regarding the ionization energies. It decreases with the size of the atom. No. As your size decreases, ionization energy increases. It increases with increase in nuclear charge. The question is to find the incorrect one, okay? So this is correct. As the size is reduced, ionization energy will increase. That is true. Okay, so it's not incorrect. I hope you're getting it. B, it increases with the increase in nuclear charge. That is also correct. This one. It increases continuously from boron to fluorine. This is incorrect. Correct answer is option C. How? Boron, carbon, nitrogen, oxygen. This is half filled. So carbon is greater than boron, nitrogen is greater than carbon. But if you compare nitrogen and oxygen, nitrogen is greater. Okay. So it's not continuously increasing. It is increasing. There's a general trend. That's all. So C is incorrect. D, the ionization energy is higher for electrons in orbitals with greater penetration. That is also true. So the correct option is C, which is incorrect. Question which was asked in December 2025. All right. So see you in the next.